The helicopter, a flying machine capable of vertical takeoff and landing, hovering mid-air, and navigating flexibly through valleys and urban landscapes, is one of the most structurally complex and technologically demanding aircraft in modern aviation. From military reconnaissance and rescue transport to aerial photography and urban commuting, helicopters play an irreplaceable role. Behind every highly maneuverable and high-altitude safe helicopter lies an industrial marvel powered by engineers, skilled workers, and high-precision equipment. Today, we take you into a modern helicopter factory to uncover how this airborne machine is built: one screw, one panel, one weld, and one line of code at a time. The manufacturing process begins with design and simulation. Engineers define key metrics such as power systems, payload capacity, range, and cockpit interface according to mission needs. Using digital modeling, aerodynamic simulation, and structural analysis, they draft a complete blueprint. 3D modeling software outputs parameters, assembly relationships, and tolerance standards for tens of thousands of components. Once the design is finalized, production begins simultaneously across several core systems: the airframe, rotor systems, powertrain, transmission, avionics, and cabin integration. The airframe usually consists of a hybrid structure combining high-strength aluminum alloys, titanium, and carbon fiber composites. Manufacturing starts with sheet metal processing, stamping, stretching, and CNC milling to shape fuselage panels, tail booms, skids, and landing gear. Technicians assemble the main body on jig platforms using riveting, welding, and bonding techniques. Carbon fiber parts are produced using molding, high-temperature curing, and non-destructive testing to ensure an optimal strength-to-weight ratio. The rotor system, comprising main and tail rotor blades, hubs, pitch links, and control shafts, is the helicopter's core. Rotor blades are made from high-strength composites with titanium spars to ensure fatigue resistance and aerodynamic efficiency. Their fabrication involves resin infusion and thermal pressing, followed by dynamic balancing and high-speed rotation tests. Hubs and couplings are held to micron-level tolerances, processed using 5-axis CNC machines, laser measurement, and X-ray inspections to guarantee precision. The power system is the heart of the aircraft, typically a turboshaft engine supplied by specialized manufacturers. Once delivered, the engine is integrated with the main gearbox, transmission shaft, cooling system, and fuel delivery lines. This takes place in a temperature-controlled cleanroom, supported by vibration isolation components and thermal stress management designs to ensure safe long-term operation at high speeds and temperatures. Avionics and sensor integration define the helicopter's intelligence. Systems include flight control computers, GPS, attitude sensors, radios, radar, and autopilot modules. These are installed in dedicated electrical workshops, with every wire labeled with direction and connector codes. Each connection undergoes insulation checks, interference tests, and redundancy validation. The cockpit is outfitted with dual displays, control sticks, throttle/collective levers, emergency shutoffs, and communication links. Once basic assembly is complete, the helicopter enters the system integration phase. Technicians test fuel, pneumatic, and electrical systems to ensure rotor pitch control, surface response, and alarm functionality. Ground tests include taxi trials, power calibration, rotor spin-up, and simulated autopilot modes. After all systems are verified, the aircraft is sent to the flight test center for real-world flight evaluation. Flight testing is performed by seasoned pilots and engineers, who assess hovering, takeoff balance, acceleration, circling, reverse flight, and emergency response under maximum load conditions. Each test is documented in detail. Upon completion, the helicopter returns to the factory for final optimization and a comprehensive quality check over 50 criteria covering structure, electronics, system coherence, and cosmetic consistency. After passing inspection, the helicopter is painted and customized with client branding. It is then delivered by truck or cargo aircraft. High-end models may include crew training, logistics support setup, and pre-installed maintenance packages to ensure global operational readiness. The birth of a helicopter is a triumph of materials science, mechanical engineering, avionics, precision manufacturing, and system integration. From blueprint to airborne motion, it passes through tens of thousands of coordinated steps and countless hours of dedicated labor. So the next time you see a helicopter circling above your city, think of the factory and the people behind it. It's not just an aircraft, it's modern industrial civilization taking flight. Subscribe to the channel. We'll see you next time as we explore the making of more airborne miracles.